We are here in section 3.1 and we're talking about vertical and horizontal shifts. So we're not only in a new section, but we're in a whole new chapter. Chapter 1 was all about introducing the idea of a function and what a function is. Chapter 2, we saw really the most basic type of functions, linear functions. And here in chapter 3, we step away for a minute from our library of functions. We're not going to talk about a specific type of function, but we are going to start talking about transformations of functions, like ways that you can move them around. And we start with this idea of shifting. So this arrow is reminding us that sometimes there are situations where we have a function and we need to shift it either maybe right, left, up, down, maybe flip it around, maybe stretch it a little bit. And that's what chapter 3 is going to be all about. I'm going to give you two functions to look at. The first one is f of x equals x squared. And this is the function, we'll call it g of x, x squared plus 2. So just based on these, what you see here, I'm going to ask you what you think the graph of certain other functions are. So knowing that this graph of this function looks like this, and here we have this function, which is very similar to this one, some slight differences, but it looks like this. What would you expect this function to look like? H of x equals x squared minus 3. Think about that for a minute. Knowing how these guys behaved, I would expect that h of x equals x squared minus 3 would probably be the same basic shape as f of x, that x squared function, but I would go down 3 units on the y-axis. And again, it would have the same basic shape, but it's as if it shifted. And it is as if it shifted because this -3 right here is shifting things up and down. So just like this plus 2 that got added on at the end shifted the whole graph up 2 units, this -3 here is shifting the original graph. Oh, whoops, 1, 2, 3, down 3 units. It's like a rigid shift. Okay, how about k of x equals x squared plus 7? So here the only difference between this function and our original function x squared is that we've added the 7 on at the end. And following the pattern of what we've seen before, we would expect something like the same general shape, 1, 2, 3, 4, 5, 6, 7, but just shifted up 7 on the y-axis. And if you graph this function, that's exactly what you'll get. So these 3 functions were all vertical shifts of the original. And this constant that got added or subtracted on the end of the original function is what causes that vertical shift. So keeping this as our original function, let's look at some other things that can happen. What would you expect y equals x plus 4 quantity squared to look like? This is definitely slightly different. First of all, just getting some practice, we can think of functions as having these names, but also we can think of a function as just y and output. So that's not especially relevant. It's just a different way of writing the function. But this is the relevant part here. This original function was taking an input and squaring it. Then these functions were taking that input, squaring it, and then adding or subtracting some constant. But here it's fundamentally different in that I'm taking an input, adding a constant, and then squaring it. So it's as if this constant gets added on really at the very beginning of the process, whereas these were kind of at the end of the process, these vertical shifts. So what would you expect this guy to look like? Should it be a vertical shift up 4? Probably not, because it's a totally different form than these guys here. Here the constant is sort of with the x from the beginning. So I'll show you what this function looks like. Okay, here it is. Here's the function y equals quantity x plus 4 squared. And is this what you expected it to look like? Right here is the y-axis, and right here is the x-axis. So how did things change from our original function? It looks like the original function got shifted left 4 units. So here we have -4. 1, 2, 3, 4. Otherwise, the shape of the graph is exactly the same. It was a rigid shift, but this time instead of a vertical shift, it's a horizontal shift. Did you expect it to go, if we were going to go left or right, it almost looks like it should go right, but it in fact does go left. So these horizontal shifts are when we're adding or subtracting a constant from the very beginning. It's sort of with the input in the beginning of the process, whatever the function's doing. And if you're adding a constant to your input, it will shift it left. Well, let me give you some examples and you decide what you think these should look like. Here we have y equals x minus 15 quantity squared and y equals x plus 1/3 quantity squared. And these are all, we call this the parent function because each of these functions is sort of a derivation of that parent function. It's just a slight difference, a slight, what's that word? Variation. A slight variation of this parent function. And so knowing how this one behaved, you probably, I'm sure, can already guess how each of these is going to behave. This one will get a horizontal shift again. And does it go left or right? Well, when we subtract from that input, it actually goes to the right. We're going to shift things to the right. So this is going to shift 15 units to the right. And this one will be a shift. Will this be a shift left or right? Let's see, we're adding 1/3. That will be a shift left, but just by a little teeny tiny bit of 1/3 of a unit to the left. So for this guy here, I'm going to, let's see, if I'm going to go subtract 15, that's to the right 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 14, 15. Okay, and then from there, so this is my new kind of 0, 0 point. The function has that parabolic shape that the parent function does. And then this guy over here, we decided it was going to shift to the left 1/3 of a unit. So here's 1 unit. We'll go 1/3 of a unit. And so this is really similar to the parent, just shifted to the left 1 unit. And so we saw these 3 examples ended up being horizontal shifts of the parent function. These vertical and horizontal shifts work for any function. Anytime, doesn't have to look like this guy, anytime you have a basic or a base function, you can perform these vertical shifts or these horizontal shifts in a similar way. So let's generalize what we're learning here. So as we generalize this, we're going to look at 2 different notations. Say you had a function and you added some sort of constant to it, or maybe you had a function and you added or subtracted a constant to the input before you even did anything with that input in the function. So this constant is part of that adding or subtracting of the constant is part of the input. So let's start with this guy right here. This we recognize is going to be some sort of vertical shift. So f of x plus k is the graph of our function f, that's sort of the parent function, shifted vertically. We know it's vertical because this constant gets added on at the end or outside of the function. And how many units does it get shifted vertically? Well, it should get shifted, let's see, k theoretically could be a positive or negative number, so we'll call it the absolute value of k units. If k is positive, k is greater than 0, then we saw it shifts the graph up. And if k is less than 0, it's a negative number, like we saw, I can't remember, -3, I think we did, then it'll be a shift down. Okay, and that covers vertical shifts. So what are the words that should go in here then? F of x minus h is the graph of our parent function f shifted, what should go here? How about shifted horizontally? And this time it'll be the absolute value of h units. And so we just have to figure out if it's going to get shifted left or right. So depending on if h is positive or negative. Shift right. Okay, let's think about this. If, for example, h was a 2 right here, x minus 2, we saw that that would mean x minus 2 would mean it was counterintuitive that it shifts to the right 2 units. So x minus 2, if h is, the minus is already a part of our definition. So if this was a 2, if h was a positive number here, then it gets shifted to the right. And if in this definition h is a negative number, which would actually make it like, say that h was negative 7, so that would create an x minus minus 7, so that would be x plus 7, then it's actually a shift to the left. All right, let's look at some more examples and get more comfortable with this. Okay, say we have some random function like this, and we don't even have an equation for this function. All we have is this picture of the function. But say that we do actually know that it goes through the point 0, 2 right here. So here are 4 things we're asked to do. Graph f of x plus 3, quantity x plus 3, graph f of x plus 3, slightly different, graph f of x minus 5, and graph f quantity x minus 1. These are all things we should be able to do at this point. So let's start with this guy, and let's kind of think through what should happen before we actually write anything down. Let's see, this is definitely, first we have to decide, is this a vertical or horizontal shift? And because the constant being added is along with the x in the input, we know that it is a horizontal shift. Now we have to decide, are we going to take this function and shift it to the right or to the left? So the rule is when you add a number, it actually shifts things left. Okay, so we are going to take this function and shift it 3 units to the left. So here I have the parent function, and I'm going to just take it and shift it to the left 3 units. And so now this point that was going through 0, 2, it's kind of this part of the curve. I can see it right here. It no longer goes through 0, 0, 2, but it should go through how about negative 3? And it still stays at its vertical height, 3, 2. So this point 0, 2 right here got moved to negative 3, 2. Everything got shifted left 3 units, but this is the one point that we definitely know here, and so we know that that got shifted left 3 units. To shift left 3 units, we would shift the x-coordinate to the left 3 units, and that's where we get the negative 3 from. The y-coordinate didn't change because this graph here didn't go up or down at all. It just shifted to the left 3 units. Okay, let's take a stab at this one now. So let's think through what should happen here. Is this a horizontal or a vertical shift? The constant's getting added on at the end, so this is a vertical shift, and we need to decide, is it up or down? And it is up, because with vertical shifts, it is what you think it should be. The plus 3 means go up 3. So we're going to take this function and shift it up 3 units. So where should this point 0, 2 go? It should go up 3 units. So here's our original function where it is sitting originally, and I'm going to take it and I'm going to move it up 1, 2, 3 units. And then I have to think, where did my point 0, 2 go? It went up 3 units, so where does that land it? Let's see, it was right here at 0, 2, and it went up 3 more units. 1, 2, 3. So here that point got shifted to 0. What should this number be here? How about 5? Okay, we're doing great. We're halfway done. We got this guy, we got this guy, and now we're going to focus on this one right here. So let's take a look. We're taking a function and then subtracting 5. That looks like we're in a vertical shift, and it's a negative 5. If this number is subtracting a number, then this gets shifted down. So we're going to take this function and shift it down 5 units. So think about where this point should go. It's going down 5 units. Will this coordinate change? It shouldn't, because this is the x-coordinate. The x-coordinate on any of these points is not changing. It's just all the y-coordinates are going down by 5 units. So what should this number, so where should this number, this y-coordinate, be shifting down to? Should it shift down to -5? No, really we're just subtracting 5 from 2, so what is 2 minus 5? Okay, so we've got the original function here, and I'm going to shift it down 5 units, so I'm going to take it, and I'm going to go 1, 2, 3, 4, 5. So it looks like the function should end up being right about here. And then this point right here, let's see, we started at 2, went down 1, 2, 3, 4, 5. So this point right here that was at 0, 2 should now be at 0, -3. Every point, every y-coordinate got shifted down 5 units. Okay, last guy. You are pros at this now, and f of x minus 1, is this a vertical or horizontal shift? It definitely looks like this guy. So the rule is when that constant's being added or subtracted to the input from the very beginning, then it's a little counterintuitive. When we subtract 1, it's actually a shift to the right one. So where should this point go? If we're shifting this to the right one, does the x-coordinate change or the y-coordinate change? Y-coordinate stays as it is. This will definitely be a 2. What will this 0 turn into? It's shifting 1 to the right. Here's our original function sitting where it does originally, and I'm going to shift it 1 to the right. So I'm going to take it and just move it 1 unit to the right. So that point that was at 0, 2, it's right here, and now it got shifted 1. It's still vertically at 2, but now instead of being at 0, it's at 1. And we finished all 4 of those. Is it possible to combine horizontal and vertical shifts? Absolutely. So now let's attempt this one to graph this f of quantity x minus 2 plus 3. So this is definitely a vertical shift, up or down? Up 3 units. And here we have a horizontal shift. Let's see, should this go left or right? It's a minus 2, so this will go right 2 units, up 3 units. So we're going to take this function and we're going to shift it to the right 2 units, 1, 2, and up 3 units. And I'm going to leave it as an exercise in the quiz to find out the coordinates of this point right here that was originally at 0, 2 and gets shifted. Where does that point get shifted to? And we'll call this example 1 so that we know what to refer to. For our next example, we're going to look at the function f of x equals square root of x, and it generally looks like this. The reason there's no values over here on the negative side of the x-axis is you can't, negative numbers are not part of the domain. You can't take the square root of a negative number, so the function doesn't exist over here. It only exists for positive x, and when it does, it looks like this picture. So here we have another function. It looks really similar to this guy, same shape, but things got shifted somehow. So we're going to be asked to do 2 things here. So here is a transformation of the original function. The first thing we're going to be asked to do is use function notation to write this new function. Okay, what the heck does that mean? Okay, use function notation. So function notation is this guy right here, and we're going to write this new function. So somehow we need to use f of x in describing this function. Use function notation to write this new function. Well, this was the original function shifted left 4 units. So when we take a function and shift it left 4 units, how do we write that using function notation? Is it that there's a -4 added on at the end? Is something happening inside the parentheses along with the input? Horizontal shifts definitely happen inside the parentheses alongside the input. So I know that it has to be, let's see, f of something is going on inside these parentheses. And I have an input, and I've just shifted everything left 4 units. So with horizontal shifts, it's kind of counterintuitive. A shift left is a +4 right here. And this is it. This is the solution. We've just used function notation to write this new function. It was the original function, but shifted to the left 4 units. And so this is the answer. The next thing we're asked to do is to write the formula for the new function. This is a slightly different question. We're not using function notation anymore. We want an explicit formula. So we want to know, we could call it g of x or we could call it y. We want to know, without ever having to refer back to the parent function, how we could describe this algebraically. So we'll say the formula for this new function is y equals, let's see, well, f of x plus 4 means that this is an input into the original function f. So that would be the square root of x plus 4. And that's it. So in this question, we had to come up with a formula for the new function. And knowing that it is f of x plus 4, which we found in the question right before, can you write a formula for this? Sure. This just means take this as your input. So wherever there's an x in the formula, we're going to use x plus 4 instead of x. When we're asked to use function notation to write the new function, there's going to be some reference back to the parent function. But when we're asked to write a formula, it's just explicitly you have your input and your output, no reference back to another formula. Okay, and then in the third example, we're going to take a look at this function. F of x equals x squared plus 2x minus 5 is our function, and we're asked to find a formula. Okay, so no f's in our formula, just inputs and outputs for the function that shifts f up 7 units. Okay, so the new function that shifts up f 7 units will be, we just really need to add an 7 units to the end of f. So we'll call it g of x, and g of x is just going to be the original function f plus 7. That'll do that vertical shift, but they want a formula. They don't want a in function notation. So f of x plus 7 would be x squared plus 2x minus 5. That's what f of x is, plus 7, and we could definitely simplify that. So g of x equals x squared plus 2x. Let's see, negative 5 plus 7 is going to be a plus 2. And so this is it. This is the formula for the function that shifts f up 7 units. Next, we're asked to find a formula for the function that shifts f right 2 units. So we want a formula. So we don't want to refer back to f in the end. We want just a formula for inputs and outputs. So let's see, but we want to shift f right 2 units. So this means when we're shifting horizontally to the right 2 units, that'll be like x minus 2 in the input. We'll call this new function h of x, and h of x should equal f of x. Let's see, should it be plus or minus 2? If we're shifting to the right, it's that minus 2. So we're not done yet. This just tells us the beginning. H of x equals f of x minus 2, but we really want just a formula for h with no reference to f. So we'll go back up here and say, okay, what is f of x minus 2? That means wherever there's an x in the formula, my input should be x minus 2. This will look like x minus 2 squared plus 2 times x minus 2 minus 5. If I truly want to find f of x minus 2, this is notation that tells me to put x minus 2 in for an input anywhere in my function f that there's an input. So right here, I have to put x minus 2. That's my input. Right here, I have to put x minus 2. That's my input. And so this is a formula for the function that shifts f right 2 units. We can simplify it, but it's fine to leave it right for now, just like that. Our big ideas in this section were being able to recognize and working with vertical shifts of functions, and recognizing and working with horizontal shifts of functions.